Welcome to our new digs. Although I notice only one of you remembered the housewarming gift, folks, it would have been appreciated, but okay. All right. And thanks for coming out in the bloody cold. You're making me doubt your sanity, but thank you for showing up. This kind of started out a number of years ago. We were out observing one night, and one of my observing buddies had a friend from out of town who was visiting. He was also an observer. He'd been observing for at least 10 years more than me, maybe 20 years more than me. And he lived in the desert Southwest. So I was just jealous as hell of him because within a couple hours of home, he had access to skies darker than anything you could find anywhere in Illinois. And since he was just up visiting, he didn't bring a scope. He just was sharing views with us while we were there. And over the course of the evening, I showed him a few things. And we got done, and he said, "I wanted to thank you for this because it's been one of the best observing nights I've ever had." And I thought, yeah, bullshit. Nice of you to say, but I know where you live. This couldn't possibly be in Illinois, folks. This was the best observing night you've ever had. There's something wrong. And there was something wrong. Because I said, what do you mean? I said, well, before tonight, I had never seen that rocket asterism you showed me in Pisces. That was cool. I'd never seen an asteroid. And I'd never seen a red dwarf. I didn't even know you could see red dwarfs. And I said, well, for Christ's sake, you live in New Mexico, for God's sake. What do you look at when you guys go out? I said, Messier objects. And I felt so bad. Because it's like we took him to Ravinia, told him he could have his pick of any of the picnics on the lawn, and he decided to take care of his hunger by catching and eating flies. It just makes you wonder. So, 2 takeaways at this point. Number 1, don't let that happen to you. And number 2, even here in crappy, light polluted Illinois, you can see stuff that can maybe make some of your friends from the desert Southwest jealous if you know where to look for them. So let's find out where we find them. We have 10 easy ways. First thing, asterisms. Constellations get all the press. Asterisms nobody pays much attention to, but there are some amusing things up there. Some of them are kind of neat. Astronomical League, if you go to their website, you can actually get the observing lists for any of their observing programs without having to sign up for the program, without even being an Astronomical League member. You can get them right off their website, and they will give you, in this case, for the Asterisms observing program, they list 112 asterisms, naked eye binoculars, and telescopes. They will tell you what they're called and where they are in the sky. We did a program on asterisms back in May of 2020, which is on the YouTube channel, and we covered 40 of them then. Cigarro Astronomy Club, which is in Phoenix. There's a guy there named Steve Coe who used to write a monthly column for, I believe it was Astronomy. This is probably 20 years ago, but he's a really phenomenal and prolific observer, and they put together a list of 113 asterisms worth chasing down. And then, of course, the ubiquitous and always opinionated Phil Harrington wrote a book a number of years ago called Touring the Universe Through Binoculars that has a couple of dozen nice binocular asterisms. And if you just go online and Google asterisms list, it'll take you to a bunch of them. Down there at the lower right, just to demonstrate that these are not necessarily things that you are going to have trouble finding, that bright star at the top is Arcturus. Okay, if you can't find Arcturus, ask somebody. It's not easy, not hard to miss. And just to the lower right of Arcturus, you can see Napoleon's hat. It's less than half a degree away, and big as life. In Andromeda, right up near Almach, there's that neat little group of stars forming that V, which looks just like the little stylized stick figure crows that Van Gogh put in some of his paintings. In the middle, asterism in Virgo called Jaws. It is supposedly, although I don't really like this one, but it's famous. It's supposedly a shark basically heading downwards, and you can see its dorsal fin going off there to the right, and its big toothy mouth there at the bottom. It's actually one of the highlights on the road to M104. If you follow the line of teeth from right to left, it'll actually point you right to M104, which is in the same field. I love the one on the right, and I really want to know what kind of psychedelics the person who first said, hey, you know, that looks like a kangaroo was doing, because, man, that's trippy. The fact that you found something that looks that much like a kangaroo sitting up there in Boetes. Saxophone in Perseus, Bill Clinton tribute. You got the mouthpiece up here, comes down, comes around, and there's the bell over there. Sailboat, there's a lot of sailboats out there. That's the one in Leo Minor. You can see the hull running from left to right, the sail going up to the right below that, and the, what do they call that thing that hangs down below? A keel? Down there below. And then, of course, the rocket ship that our friend from the Southwest found so intriguing in Pisces. It's easy to find and sort of evocative, I guess, in a 1950s sort of way. Asteroids. Easy to find. Astronomy magazine is real good about pointing you to one that's going to be not too hard for you to dig up almost every month. Sky and Telescope, for some reason, doesn't seem to like them. I put them in Rick's picks when they're brighter than Mag 9. We have, again, YouTube channel has a fundamentals program on them. The Observer's Handbook will tell you any of the ones that are going to reach opposition at Mag 10 or more during the course of the year. And if you have Stellarium or some other planetarium program that's up to date, you can find out exactly where they're going to be on any given night. A purist is going to tell you that you can't really say it was an asteroid unless you come back 2 days later and it's moved. Well, yeah, bullshit. Asteroids are neat in that they all seem to have this very distinct coppery color, and they all have a patina or a sheen that is very different from a star. Usually if I'm showing somebody an asteroid in the field and they say, which one's the asteroid? If there isn't an easy answer to that, I can usually get them to it just by saying it's the one that doesn't look like all the other ones. And there's usually 5 seconds of silence and, oh yeah, that one. So it is easy to tell them when you've got them. You will know if you've got it or not. If you want to come back in 2 days and show that it moved, that's fine too, but I don't really think it's necessary. Carbon stars. Carbon stars are wonderful. To get a carbon star, you start with a red giant. So you've got a star that has used up all of its hydrogen, and now it's converted all of its hydrogen to helium, and now it's burning helium, which does not burn as hot as hydrogen does, and so the star is not as hot as it used to be. And because star colors reflect their temperature, when we get the red giant phase, because it's burning helium, it tends to turn red. So we got a little bit of redness from that. And then on top of it, one of the elements that the helium burning phase produces is carbon. And the carbon sort of precipitates out in the stellar atmosphere. Outside of it's not, down in the nuclear furnace, all this stuff's going on, nothing's going to precipitate out there. But as it goes out towards the outside of the star, the carbon that was made down in the core starts to cool, and it literally turns to soot. The same crap that you'd find in your chimney. And the light coming out of the star, which is already red because of its temperature, it hits the soot particles, and it does the same thing that it does in our atmosphere when sunrise and sunset happens. The blue end of the light scatters, the red end of the light comes through. So with a carbon scar, you have sort of a doubly red star. Red because of its temperature, doubly red because the carbon in its atmosphere is knocking the blue out of any remaining blue out of the picture, and what comes through is a very pure red color. The drawback with them is their redness is inversely proportional to their brightness. So perversely, they're most red when they're hardest to see. Still, even when they're bright, they're pretty nice red critters. You get that color down there. I think that's the one called the stoplight for obvious reasons. It's in Cepheus, and they say again the Astronomical League's observing program will point you to 100 of them. Cigarro's database has a red stars list, not necessarily carbon stars, but Cigarro's red stars list is worth looking at too, because it'll give you an idea of how red the stars are likely to be. Since we're on colored stars, let's get some color contrast going with some doubles and multiples. Not just Alberio anymore. Here the Astronomical League is not quite as helpful because they never mention color. And that's likely because, it does tend to be subjective. What you see is not necessarily what the person observing with you is going to see. It's not necessarily what the person who wrote the book that you're using saw. So the Astronomical League kind of stays away from that. Cigarro reports the colors that their observers saw when they added them to the list. And there's a very well-known book by Sissy Haas called Double Stars for Small Telescopes that lists literally hundreds and hundreds of them. And when there are colors to be seen, she mentions it.
The library has that book.
Pardon?
The library has that book?
It should if it doesn't.
It does.
It does, okay, good. Yeah. So, they come in all kinds of colors. I mean, the blue and yellows, like Alberio, are probably the most common, but they come in an awful large number of shades. I mean, if you look at Delta Cephei down there at the bottom left, and compare it to, even if you just compare it to Izar, for example, in Boetis, the blue is definitely different. Yellow is a little different. Get some interesting ones with funny purplish colors, like in Eta Cassiopeiae. You don't really see it as much in the photograph, but when you see it live, the contrast with that bright yellow star makes the secondary look really distinctly purple. Pi Andromedae, the powder blue color of that secondary star will literally take your breath away. And then, of course, you get the car headlights coming at you out of the depths of space with things like Algeba and Prima down there at the bottom. So lots of good things to see in the double star department, and you can. Tyler Hunt, who died a few years ago, he spent years looking at double stars and cataloging them, measuring them. and he never ran out of stuff to look at. So include that on the list. Oops. In fact, include it twice. Another thing to consider is once in a while do a deep dive into some of the deep sky objects that you're looking at. It's fine to say, hey, there's a double cluster. All right. Now, what about the double cluster is interesting? And if you start looking more carefully, you find out, number one, there's some pretty big differences between the two clusters. I'm not going to tell you what they are. Next time you're looking at the double cluster, look at it and it'll jump right out at you. But it's something that you have to actually decide you're going to do. The Beehive M44 has a lot of stuff going on in it. The Coma Star cluster, and then there's even the Pleiades. You look at all those doubles, and the doubles and multiples aren't. They're not necessarily just your standard two stars near each other. I mean, Eta Tauri, you get a primary in this neat little Mag 8 triangle of stars sitting off to the side, like almost like a kid running away from home with a thing over his shoulder. O Sigma 64 is a triple with all three stars literally in a almost perfectly straight line, which is kind of neat. And then I get the little Alley's braid asterism coming off the back of the dipper. It doesn't look all that gorgeous in the chart, but live. Live is just absolutely beautiful. And of course, there's that little south double inside the dipper, and all of these hot blue white stars in the Pleiades, and this one defiant little red guy just standing there saying, yeah, go ahead, do your best, I'm still red. And it's kind of inspiring. But like I say, you got to take the time to look at it. Along the same line, putting the moon in the eyepiece is fine, but actually getting in there and looking at the stuff, wow. There is some neat stuff on the moon. You'll definitely need a moon map to use at the eyepiece to go from crater to crater. If you're using a refractor, they always make reversed image maps. There's some freeware called Virtual Moon Atlas, which I definitely recommend. You can print it out as you would see it in a refractor, as you would see it in a reflector, pretty much as you would see it standing on your head if you want. There's also, NASA has a moon site. I can't remember the name of it, but it also is a very good site for putting up an image of what exactly the moon is going to look like and where the terminator is going to be as seen from your location at the time you're planning to observe. And that, with the moon, what's on the terminator makes all the difference. So it's something you want to know. And between the NASA site and Virtual Moon Atlas, you should be able to figure that out. You should have at least one good lunar observing book that you've gone through to figure out what's worth looking at and why it's worth looking at it. There's a number of them in the NAA library. We did a fundamentals on that in August of 21. Also on the YouTube channel, there's dozens of craters and other features in there that we highlighted. Charles Wood is a lunar geologist, did a column in Sky and Telescope every month for many years. Now he just shows up from time to time, but he put together something called the Lunar 100, which you can get from Sky and Telescope, and it's a list of progressively more difficult features on the moon that are all fascinating for one or another reaon, and Wood explains why, which is makes it much more fascinating. Again, Astronomical League, they give you part of the information, but not the whole thing. They have lunar observing programs, but they just list the features. They don't tell you what to look for or why you should be looking for it, so it's not as helpful as it might be. But when you start looking close, you can spend an hour reading Charles Wood's description of what made Posidonius look like that, and just, you know, you'd be dizzy just thinking about all the things that happened along the line to make that crater come out the way it is. You get beautiful recent craters like Copernicus with all the detailed terracing in the walls, all the sharp lines that you see in there that have not yet been worn down by lunar weathering, the multiple central peaks, features on the floor. Plato, when you look at it closely enough, you understand why the old guys sometimes talk about testing the resolution of their optics by counting craterlets on the floor of Plato, is the phrase they usually use, which doesn't make sense until you start looking at real close at some of the Plato images and realizing how many increasingly tiny little dots there are on that dark surface. Lava ridges are fun, the waves on the oceans of the moon. Valles Alpes is a valley that runs through the lunar Alps. There are a lot of valleys. Some of them, most of them are grabens. They're where two faults separated the land between, or the terra between them dropped. But other times, valleys have been formed on the moon by the Imbrium impact, where the rock that was thrown out by the impactor just literally chewed out a valley hundreds of miles long. Marius Hills, there's some other features like that. Little, very small, very subtle. You need to look for them carefully and kick the magnification up. Remnants of old volcanic features. Catena Davy and other catenas, basically where the impactor broke up on the way in, and rather than leaving one hole, it left a whole series of little ones all in a line. And then Hyginus Rill is again another volcanic feature. It's a bunch of volcanic pits that you can actually see the series of them connected by areas where the terra above it has come apart. And it's pretty neat easy to find, easy to see, and neat to think about what it is that you're looking at. So the moon. NGC planetaries. Everybody looks at the dumbbell, everybody looks at the ring, and then they go on to some other damn Messier object, but it doesn't have to be that way. If you just look at that collage that I can't remember who put that together, but somebody put together that collage of all the a whole bunch of different NGC planetaries, and forget about the colors because you're not going to see the colors in an amateur-sized telescope, but just look at the shapes. I mean, the different shapes that these things come in, and it's fascinating that they do it, and also the process through which they did it is usually even more fascinating. But just the artistry of what they ended up looking like, even in black and white, is pretty impressive. And there's a bunch of the Box Nebula in Ophiuchus, blinking planetary. You can almost make that blink just in the image with the central star and the extended part. Eskimo, just amazing detail. Blue Snowball, Little Gem, and the Cat's Eye, all relatively easy to find. Sometimes they'll surprise you. I can't tell you how many times I thought that I had missed the blue snowball and then realized, hold it, not enough magnification. Crank the magnification on the same object that I was looking at, and nope, not a star. Definitely not a star. Definitely the blue snowball. So they do need some skill sometimes, but you will learn that fast enough. If I can do it, you can do it, and it opens up a whole box of stuff. I know Frank Kleikar spent an entire summer one year. This is back when he used to still come out to RR, and I remember he brought a 12-inch LX200 out there and spent the entire summer just doing planetaries, and used to love to go over to his scope and see what Frank was looking at this time, because he had a lot of the weird ones in there. Red dwarfs. Come on, they're the most common stars in the galaxy. Why are you all ignoring them? Jesus. And yes, you can see them in amateur telescopes. We were at a outreach event a number of years ago, and I had a little 90 millimeter scope, and there were some high school kids there, which is kind of nice because it's not trying to show the universe to a 6-year-old, which has value, but it's not the same as someone who has at least some understanding of what you're talking about, and was trying to show them the red dwarf component of the Castor system, and my scope just wasn't quite big enough to make the red dwarf pop up. And I looked behind me, and another guy over there had a 6-inch scope that looked like it was pointed in the same direction. I said, "Hey, you got Castor in there?" I said, "Yeah." I said, "I'm trying to show these guys the red dwarf component. Mind if I send them over to your scope and you could show it to them?" And he said, "Ho, ho, ho. Who are you trying to kid? You can't see a red dwarf in an amateur-sized telescope, and you can't write this shit." So I said, "Well, maybe not, man, but there's one in your eyepiece right now. Would you like me to show it to you?" And it's gratifying sometimes when you just shut them up, But I showed it to him, and then he showed it to them, and then we all show it. And if like I said, if you can find Castor, you can find at least one red dwarf. At least you got a 6-inch scope. Barnard's star is also remarkably easy. I mean, everybody knows Barnard's star. It's over there on the right-hand side. The star at the lower left corner of that image is a naked eye star in the Bull of Poniatowski. That's the little V-shaped asterism in Ophiuchus. And anyone who's visited Barnard's star will recognize that kind of triangular-shaped bunch of stars at the upper right. They slope down, and it kind of slopes back and makes a little box. And I think of it as the shark's snout. And if you follow the edge of the shark's snout down, you see that little red guy sitting right there, almost like it's the 4th star in that line, and that's Barnard's. So, and it's that easy to find. Like I said, if I can do it, you all can do it. We have a couple of years ago, I did 2 special editions of Rick's Picks covering 35 red dwarfs, and we've got the finder charts and all that, so it'll take you right to them. And if that's not enough, you Google red dwarf stars, it'll give you more. But like I said, they're everywhere. They're nice to find. They usually do have some redness. They're not as red as a carbon star, but you can see why they're red dwarfs and not something else. And they're worth putting on the list. White dwarf stars, very, very few and far between, but there are a few. And it's timely because if it ever gets warm enough out between now and the spring to go out and set up a telescope without freezing to death, put it on Sirius, center it, kick your magnification up to at least 300 power, and turn off any tracking, and just watch, because the primary star will float out of the field, and you will see the pup which is Sirius B. It's that little Mag 8, I believe, if I recall correctly, white dwarf that's paired up with Sirius. This is the last, well, it's not really the last year when you can do it, but for a number of years, it's been lined up in a way that, it's basically an east-west lineup. So as Sirius moves out of the field, the pup is following right behind it. It's going to be twisted starting next year to a greater or lesser extent. They're going to get more twisted as time goes on, but it's certainly this spring you still have an opportunity to see Sirius B without much, well, really not much effort. And of course there's the star 40 Eridani. You gotta love this. Something for everybody. You got a Mag 4 yellow dwarf, a Mag 9 white dwarf, and a Mag 11 red dwarf, all in the same system. So that's certainly worth hunting down. And again, Cigaro has a database with where they have a dozen white dwarf stars, and that goes down to Mag 13 because, like I said, there's not a lot of them, and they do tend to be faint. So the only ones I've ever seen were Sirius B and 40 Eridani. Some people like to count the central star of every planetary they've ever looked at as a white dwarf, but I don't think that's that ain't what it's about. And then finally, this is an idea that actually the Astronomical League put a name on. They created a 2 in the view observing program, and what they did was they found about 100 examples of situations where you'll get more than one deep sky object in the same telescopic field. And some of those can be kind of interesting, so they're worth hunting some down. And the same thing works with double doubles. You get more than one double star in the same field. Up along the Cepheus Cygnus border, there's a galaxy and open cluster, NGC 6939 and 6946. If any of you ever observe with Rick Bedecker, which is really a privilege if you ever have the opportunity. But I can almost guarantee you that somewhere during the course of the night, he will say, "Hey, come on over and look and tell me what you think of this." And I guarantee you that when he says that, he's suckering you into trying to pull these two out of his eyepiece. And unfortunately, since they're circumpolar, he can do it every night of the year. So that's the bad part about it. But it is kind of nice. Actually, you can do those in binoculars. Personally, I found it easier to spot them in binoculars than in the telescope. M53 has a shadowy globular cluster right kind of next to it and kind of way beyond it, called NGC 5053. If there is a better illustration of the effects of distance on what we see in the sky, I don't know what it is. And then over there on the right, you need quite a bit of magnification to see these guys, but there's a couple of very unusual galaxies. You got the Whale up at the top right, and a little satellite galaxy called the Pup right next to it, and then this warped spiral, called the hockey stick, down below it to the left, but again in the same field. And there's, they said, the Astronomical League has about 100 examples of things like this. And then finally, you get the 2 in the view double and multiple stars. It's not just the double anymore. That one at the top left, Xi Scorpii in Struve 1999 is really sweet. It was just nice, really warm colors. The one underneath it, the double Struve pair in Lyra, is remarkable. Both the type and the magnitude of these stars are almost exactly the same between the two pairs. The separation is almost exactly the same, and the position angle is almost exactly the same. They're very literally twins of one another. And then, of course, you get these other guys, Sigma Orionis, which a lot of people think is a single star system, is actually two triple systems right next to each other, and some of the other ones as well. So, now that you got that, get out there, look at stuff, get past the Messier objects, and remember to give John Abrahamian a hard time about his pasty white legs. So, other than that, and that's all I got.